orifice is. So we have to determine the discharge at the orifice from the figure shown. So we have here our figure which has a closed tank in which we have a partition inside to separate the two chamber, the chamber 1 and the chamber 2. Since this is a closed tank, we have our air pressure which has 85 kilopascal in chamber 1 and 45 kilopascal in chamber 2. So we also have an existing head from the orifice to the liquid surface. In chamber 1 we have 8 meters, and the orifice from the orifice to the liquid surface which has 4 meters in chamber 2. So this tank has filled with water. So what we are looking for in this problem is the actual discharge at the orifice. So the actual discharge. So the formula for this actual discharge is QA equals to CAO times the square root of 2 times G times the big letter H. So our C here indicates the coefficient of the discharge, while our A is the cross-sectional area at the discharge in the orifice, multiplied by the square root of 2 times G, in which our H depends on the existing energy that triggers the discharge at the orifice. So first we are going to find our H. So since we have two chamber here, we have two chamber 1 and chamber 2, we will subtract the HU minus HD. So the head water from the upstream reservoir minus the head water from the downstream reservoir. So how can we find, or how can we determine if this reservoir is the upstream reservoir or the downstream reservoir? So based on our figure, it is very obvious that our upstream reservoir, we can find it in the first chamber because it has a higher head water and also a higher amount of air pressure. So this chamber, this part is our HU and this part is our HD. So H is equals to P sub 1 all over gamma plus the H1 minus P sub 2 all over gamma plus H sub 2. So we have here our H, our P sub 1, which is the 85 kPa all over 9.81. This is cubic kilonewton per cubic meter, since we are using kilopascal in our air pressure. So plus our H1, which is 8 meter, minus our P sub 2, which is 45 kilopascal all over 9.81 plus our H sub 2, which is 4 meters. So our H is equals to 85, 9.81 plus 8 minus 45, 9.81 plus 4 is equals to, so our H is 8.07747 meters. So we already have our H here, which is 8.07747 meters. So since we already have our H, the value of our H, we will now proceed to the original formula, which is QA equals to our coefficient, which is given here, 0.96 times our area, which is pi, times our diameter, which is 78 mm, and we will convert this into meter, which is 0.078 meter over 8 times 2 9.81 times our H, which is 8.07 times 8.07747. So we have our QA equals to, solve pa ko, wala na ko sinolve. So our QA is 0.0288740 cubic meter per second. So since we are already done solving, we already have our QA, or the actual discharge, in our orifice, which is 0.0288740 cubic meter per second. So that would be all in our video. Thank you so much for listening, and thank you so much for watching.